So hi, I'm Aaron. This is me here. This is me Halloween edition. So if you ever lose me in a crowd around October, that's what to look for. I work for Elastic, community advocate there. You can email me if you want to talk. I've got my Twitter is usually where I talk to people. I would love for you to tweet about things and talk to me there if you have questions about this and whatnot. My slides should magically show up at the bottom one, but this is the first time I'm trying their magically show up feature, so no promises. Elastic theoretically pays for me to be here. We make software and stuff. We're hiring, but we have a pitch later, so we can move on. Cool. So this is the hands-up interactive part. How many of you deal with monitoring as a job function? Like this is something that you do. You probably operate the system. You care about that. Like some people. Cool. How many of you touch monitoring in some way? Maybe you instrument software so that it can be monitored. All right, less people. Interesting. What do you monitor? These things? Do you care about uptime, performance, resource utilization? All those things? Why? Money? That's good. I have a theory. One is things fall apart, right? Stuff breaks, and we want to know when it breaks because incidents suck, especially if you're finding out about them late, and then like all your tools start breaking on top of it. So we want to know about it ahead of time, right? We monitor because we want to find out if stuff is going to break. A lot of times, did we have people that identify as ops engineers? Are we still in the room? Like a handful of people now? We're all software. Cool. Well, I'm going to give an analogy then that less of you will be able to relate to, but maybe will provide insight instead. There's a great video, and I think monitoring usually ends up as kind of an ops function. I don't think that's a bad thing. That's kind of that specialized area where you're actually operating software and making sure it goes out to people. I think in a lot of ways we monitor that system stuff because that's sort of the domain of control that ops traditionally has. So there's a great video out there, you may have seen it, I think it's on YouTube, where there's like people in a sound booth and someone's gonna sing and the producer's like, all right, let's go change the world, right? So they start singing, it sounds fine, but as the camera pans from the control booth to the actual recording booth, it goes through the wall into the recording booth, it sounds awful. The singer is not on key at all. Notes are everywhere. It's like, oh, say, can you? Like, terrible. And as it pans back to the recording studio, the control booth, the sound engineer is breaking a sweat, turning dials and knobs, adjusting sliders, and it sounds amazing. In a lot of ways, that's kind of where ops exists. We can't necessarily control what's coming into the system, software-wise. We don't always get control over that. But we can sort of operate this one point that changes what the user's perspective of that is, adding resources, changing the resources that are available to make sure that the user has a good experience. This is sort of like, we wouldn't be DevOps Days without wall of confusion, especially not your first DevOps Days in Houston. How can we not have a wall of confusion slide, right? This is kind of where it exists. We have opposing desires, right? Development wants to disrupt, they want to innovate, they want to make changes, and operations traditionally wants to maintain stability. That's what you're paid to do. You're paid to keep the systems working. You communicate largely in tickets, which is terrible. And so we want to do DevOps and tear down the wall and kumbaya, and everybody's going to love each other. We're going to work together, and from a monitoring and uptime standpoint, we can achieve 100% uptime, right? Like this is the goal. Or not really, 100% is unrealistic, but maybe 5 nines and we can repent for that last one, right? This is my Martin Luther moment of Heresy and Evangelism. Just a minute. Except he was German, so eine Minuten bitte. This is not the point. Nines don't matter. Heresy. Right? Your nines don't matter, but it's true. Nines don't matter if your users aren't happy. This is a quote from Charity Majors, who likes to say big things that make people upset. And so I'll attribute her. But it's true, it's absolutely true. From a user's perspective, they do not care about your system health. They don't care. A quote from an actual CEO was, I don't care if our data center is on fire if we're making money. It's lightly interpreted by Cake, I think, in the single. So it's absolutely true, though. As long as your users are deriving value from your services, they don't care what your resource utilization is. They don't care how many nodes you have. They don't even really care whether or not you're using Kubernetes or AI. It does not matter, as long as they're getting value out of the services that you're providing, which is great, because that means you don't have to care either. So how about this question? How does your business make money? Do you know, as an engineer, how your business actually makes money? And I don't mean from a standpoint of we sell a widget and people pay us for the widget. Do you know how a customer moves from a prospect to an actual sale to a repeat customer? Do you understand that actual sales pipeline? Because that's the value for the business. And if you do understand that pipeline, how do you help? Where do you fit in that pipeline? If you don't understand how you help provide value for the business, your next, I need a raise conversation is going to be hard to have. Because if you can draw that line and say, hey, I do X, and that makes us money in this way, that's a way better way to justify a six-figure salary than, I don't know, I keep the systems on, and people use systems. Obligatory Deming quote. I don't think I got the full trifecta, but we need Deming in for a DevOps Days too. So it's not good enough just to do your best. You have to also know what you're doing. This is what we talked about. DevOps is about delivering value. It's not about sitting around and singing Kumbaya. I mean, that's great. That's a great side effect. It's a nice thing. DevOps does good things for the relationships between the people on your team. But it's about delivering value. That's why businesses care about it and why they want to implement it. This conflict that exists here is problematic because it damages the value that your business can actually provide. It damages that ability to go from delivering software, innovating, and keeping it operational, and making sure your customers are happy. OK, so we're going to take a break and talk about SRE. Does everyone know the SRE acronym? No. Site Reliability Engineering is what we're going to talk about. We're going to talk about more acronyms that all begin with S. So this is all that I'm going to dive into from the SRE world at the moment, but there's probably other stuff too. These are all service level indicators, service level objectives, and service level agreements. We're talking about services, not systems, right? We need to fundamentally think about what we're providing differently. We're not operating systems, and we're not writing software. We're building services, right? I know, software and systems don't matter. OK. So site reliability engineering, SLI, so these indicators, these are trying to answer the question, what is available? What does it mean for my service to be available? That might be defined differently depending on what service you're providing. SLOs talk about how much availability do we actually need. SLAs usually involve money and people outside of the engineering department. We're probably not going to talk about SLAs. Probably not. I wrote the talk. I don't know. We'll find out. So what are some service level indicators? What are the types of things you care about to figure out if your service is available? What are things that you measure? You can just yell things. Uptime. I think that's my first one. Yes. Is it up? Perfect. What else? That's my third one. So how about another one? Errors. Yeah, exactly. Errors and latency. These are primarily what we're caring about, right? And in some way, we need to give them meaning, so we probably have to wrap some number of percentiles or medians around this so we understand what part of our user base are getting latency and errors. This is the universal warning for averages. Averages hide data. Don't average your numbers. Look at this graph here. Look at this graph. Look at this graph here, though. You can see the average response time is 165 milliseconds. That means half of your audience has a worse response time than 165 milliseconds. Your top 95th percentile is at 1,000 milliseconds, and the top 99th is at 2,500. That is awful. Your service is not working. How many users do you have? If you have 1 million users, that means 50,000 of them are having a terrible experience. It's not great. So this is the type of thing you want to get to with an SLI. I'm not going to dive deeply into how to do this, but this is the concept you want to start thinking about. You want to start thinking of your services as available from the customer's point of view. So if the 99th percentile of latency requests received in the last 5 minutes is less than 300 milliseconds and we're returning an OK status, we're going to consider our service available. That's all this means so far. The service exists. OK, so service level objectives. How much availability do we need? How do we determine this? I don't know. How many 9s do you want? Is 5 good? Do we want as much availability as possible? Well, consider something. Each 9 of availability that you provide is exponentially more expensive. And that's not just from a standpoint of how much robustness of hardware and architecture and engineering do we need to make it available, but also in the cost of innovation. You're losing out on the ability to change stuff because you have to keep it operational. I was going to talk about numbers, but this chart is kind of telling. 5 nines of availability is an average of, 863 milliseconds of downtime a day. So to a customer, that means, oh, let me try and access the service. Huh, that's weird, it didn't work. Oh, there it is. Do they care? Do they care in that time that it went, huh, that's weird. Oh, now it's working? Probably not. So 5 nines of availability isn't giving you any value at that point. A good SLO barely keeps users happy, right? They want to be happy with the service. They want to be satisfied with it, but you don't want it overperform to the point that you're spending engineering that's not getting any value back. So think of this example. We do like bars and restaurants in Houston, right? So there's a bar that closes at 2 a.m. They open up at 11 a.m. every day. Does anyone have like quick maths to know what availability they have? No, it's good. I wrote it down already. So it's roughly 62.5% availability. That's what their availability is. Is anyone complaining about that downtime? No. They've accepted it. It's good for their customer base. And this isn't counting times where someone orders a beer and the keg's kicked and they have to replace it, so there's an error there. It's not counting times where it takes longer to get their orders because they're at capacity, or when someone has to be turned away because they don't have any more tables or wait staff. None of that is counted in that 62.5% availability. So realistically, it's less than that. You don't want to just ignore these errors. You do want to care about them. Because at a certain point, you care that someone keeps ordering the same beers over and over again, and we keep not having them. We should probably order more of that beer. If we have to keep turning people away, there's probably an opportunity to make more money, either by being open more hours or hiring more wait staff. So we care about these errors, but just having 1 or 2 here and there aren't a big deal. These create error budgets, right? You have a budget of errors that you can tolerate. Errors are good to have. Heresy. No, but it's true. So this error budget that you've created now, you've now got a way to justify your business value. You have a mechanism for balancing that difference. As Waldo was talking about, right? You want to balance the sort of stability versus changes that are going in. Error budgets are a way to create a business argument for why you need to move your tech debt from your backlog to your operational stack, your current sprint. Because we've blown through our error budget. If we keep doing this, we're going to lose customers. Great, you've got a great business reason. You set an error budget, you're going to violate that unless you start building stability into the system. That's a great reason to pull your tech debt off your backlog. Or you've had that really innovative, risky push to prod that you really want to do, but you're not sure what it's going to do. Well, if you've had near 100% uptime for the past month, push that change. Your customers will tolerate the failures at that point. You've already built in that error budget. That's the time to do it. SLAs are usually about money, and we're still not going to talk about SLAs. So what about the fire, right? This is sort of where we're at right now. We've got a good way to determine when there are problems. This is not fine, really. Diabolical laughter, we can joke. Okay, so we've got a mechanism for finding the fires, but we don't know what to do once we have them. How do we actually debug them? And this is when we talk about observability. If you're tweeting about it, this saves a lot of characters. If you haven't seen this, this is because there's 11 characters between the O and the Y, and Twitter has a character limit. So Ollie it is. Have people heard of observability? Do we know what it is? How many people actually feel that it's kind of just monitoring with a different name? Like it's legit. There's no, this is a safe place. You can put your hand up if that's honestly what you feel. I kind of feel that way too. But this is my talk, so I can say no. So this is, I couldn't find a good succinct, like don't put more than 7 words on a slide definition for observability. But this is roughly what it is in the least like philosophical way that I can imagine. You want to talk about a system is observable when you can ask arbitrary questions about it and receive meaningful answers without having to resort to writing new code against it or command line tools. So the gist here is that our systems are changing, right? We no longer have these obvious problems, so we need to be able to ask unexpected questions of our systems and get meaningful answers back. It's about debugging in production and diving into those unexpected problems. So like microservice abstraction, the fact that we're building containers and virtualizing away from our actual metal systems solves a lot of our weird, like obvious hardware problems that we used to have. Microservices kind of fix a good majority of the problems we used to experience. Does anyone know what this is? It's a lamp stack. So I have 4 kids, so sorry. So traditional architecture, right? It's something that we understand. We fundamentally understand operating code. Do people still operate like software installed in an operating system on a server they can like go turn off? Sure. Yeah, okay. So this is where traditional monitoring comes in, right? It's understanding predictable problems. Like these are the gist of it. There's linear relationships between the system health and the user experience. We can actually predict, hey, users are going to have some latency issues because I can see the resources on my box are being taken up. These are an obvious relationship that we have. You can probably draw how those are modeled, how those exist in the world. You can probably draw the model of how that service is delivered. These are more like complex systems. Complex systems involve lots of moving parts that you don't always have control over them, let alone the linkage between them. They're always changing. They're difficult or impossible to model. Emergent behavior is kind of an issue. So you suddenly realize, oh, we didn't expect that error to happen at all. We never have seen that pattern of behavior before. This is what happens when you start building containers and microservices for everything. Feedback loops are a thing. So like cascade failure scenarios can exist. You can also have good stuff that happens with that, but cascading is a problem. Some complex systems can have a memory about how they react a certain way, and they don't continue to make the same mistakes, or they continue to make the same mistake for a different reason. And they can be nested. You can build complex systems inside of complex systems inside of complex systems. Like you've got a business organization that's a complex organism in itself, made up of different teams that are made up of different people, made up of cells, made up of, right? All these things exist in a complex world, and by building them bigger and bigger, they become more impossible to model the truth of what's actually occurring. This is how we're starting to build our computer systems. We're abstracting further and further away and making them more and more complex. I just want to throw in that root cause is a myth. When you have that many moving parts, there's probably not one that causes a problem, especially if what actually was the issue was one service failed, which caused a feedback loop for another service, which wouldn't have failed except for this feedback loop, but now that's causing, like you've got all these different moving parts that are causing issues. There's not one that's going to cause your cascade failures. There's not one single failure that's going to cause everything to go down. I'll talk about this in a talk later, so stay tuned. Oh, right, root cause is a myth, heresy. Cool. How many people have heard of the 3 pillars of observability? You've probably been marketed this to by, like, probably my company too. Do you know what they are? They're like metrics, logs, APM. Right, open tracing. Oh, that's 4. 4 pillars. These aren't pillars. 4 pillars of observability now. No, I'll come in again. So, I mean, this is a little bit weird. It's like saying the pillars of carpentry are hammers and nails and saws, I guess. Those could be 3 pillars of carpentry. Why not? No, we're dealing with tools, not pillars. Like, because there's nothing about logs, metrics, APM tracing. There's no inherent function of them that gives you observability. I mean, if you want to go back and you just don't really want to change how you actually think about your systems and you want to just install stuff and have an observability, go with the 3 pillars. Go install something that will give you those solutions. You will have more data than you know what to do with. You will theoretically have some observability into your system, and you will have bought an observability. But we need to start understanding how the tools function together, or else we're just flooded with more data, and it's impossible to sort through. So we want to go through a little bit. Metrics. Metrics are great. They're not great on their own because they're largely context-less. They usually tell you some number over some amount of time about something. Tagging is good to give you more information about those metrics. I don't know, Datadog has like 1 million tags you can tie to a metric now, something like that. But it's all about providing context. We need to understand what this metric means. Where does it exist in our system? How does it operate? But they're really easy to store because they're small. Collection can be a pain. Check out Open Metrics. It's a way that we're trying to figure out in the broader, like I think it's the CNCF project, how can we actually collect metrics in a meaningful way that we don't have to rewrite the ability to collect metrics for every piece of software we use. But they can give you lots of data. They're really easy to store, but they're largely contextless, and this is sort of the problem that we have. We care about the tags because we care about cardinality. Is anyone familiar with cardinality? Do we want to like level set what we're talking about here? Yeah, so generally you're talking about a tag that could have a large number of unique values. So these are probably useful for troubleshooting your problems, right? User IDs, that would be useful. Like shopping cart ID, that's probably pretty amazing. Process IDs, all this stuff, for each service that you have. If you have 10,000 users, you've got a tag now that can have 10,000 different unique values. So you've got an issue with storing these as metrics. Shopping cart IDs are pretty amazing. You see, all of these can exist. If you have 1 million users, you've got 1 million different values that can exist for this. But the problem is when you're starting to deal with complex systems, 1 in 1 million is your bread and butter, right? You're not dealing with the, oh, we've had this problem 1,000 times. Like that one you're going to automate away and you're not going to have that problem anymore. The issue is those problems that pop up once in a while. But think about 1 in a million chances, right? What are the odds that you personally are at a point in your career that you are in this room listening to me talk right now? Right? 1 in a million. They happen all the time. So if you have a very large, complex system, 1 in a million chances are happening constantly in your system all the time. Being able to slice your data and filter out by like when the user calls up and says, hey, I have a problem with X, and you can immediately slice to that user's interaction with your system, that is going to save you tremendous amounts of time. Because we're not looking for a needle in a haystack, you're looking for a needle in a needle stack, right? You want to find the specific needle. Figure out how to identify all of them differently. Okay, so metrics aren't great at cardinality. Events are better, which are kind of logs. Logs by any other name. There's some arguments about events don't necessarily have to be flushed to disk like logs do, but I don't know, I think we're largely mincing words. If we're dealing with logs, please stop writing these logs if you're a software engineer in the room. Like, these logs are terrible. Parsing text is hard. How many people are actually using like the Elastic Stack or Elk Stack in some way to deal with logs? So probably everyone that's dealing with logs. This is what happens to them once they get stored in that system, because this is how they get structured. So if we're writing logs like this, you're spending resources to make them look like this. Just write them like this. Your log should output structured data. Yes. So you want to have as many keys and values as you can have in your log output. All that cardinality can be dumped into an event when a user touches your system. And there should be lots of those events every time a user touches your system, for every system that they move through. If they're moving through 10 different services just to log in, because they might have a front page UI, they have to load your assets, they have to actually pass their credentials through, and they have to get answers back. All of those things should generate an event so that you can correlate them on the other hand. So yeah, generate lots of events. Those become difficult to store. So sampling is the way that we want to kind of cut that up. This isn't about how to sample. You sort of have to figure that out. But for example, all of your 200 OKs, you probably don't need all those. You probably don't need all billion of those that you have. So you might want to take 1%, 0.1%, whatever makes sense for your organization, how many you're getting. Just so that you understand what up looks like, but not enough that you need to slice every single OK that comes through. But your errors, you probably want to keep every single one. Like the 50x errors, like you probably care about every single error that happens. Cool, let's talk about APM. APM's great because it starts to look at your systems differently than you have if you've been operating them normally. APMs already start to take the perspective of the application and how it's performing in your environment rather than what your environment looks like. So this is already some way that you're going to start seeing latencies and response times. It's going to start slicing up by percentiles probably automatically if it's an APM product that's out there that you're using. Histograms are really good. You can kind of see it at the bottom here. This long bar graph is a histogram of the response times. So you can actually see this big chunk that's really low. These are not your problem cases. You're not dealing with those anymore. You're dealing with this long tail of one-offs, 1 or 2 transactions that have weird issues going on. And that's why having all this depth of observability and being able to slice by those becomes really important. Distributed tracing is a lot of times included in APM products now. This is about the depth of that transaction. As someone moves through your system and say, we want to load the top 10 restaurants off Yelp. There's probably a bunch of different systems they interact with that all have different calls, all have different responses. These let you follow that depth of transaction throughout your system. This is so you know if you have problems, you start to understand where to look and where to find those problems throughout your entire environment. These require instrumentation. So APM isn't something you magic install and magic works. You have to instrument your code so that it actually is outputting data to your systems. There's lots of ways to do that, so I can't tell you how to do it. SLIs are a good place to start, though. If you have other responses and other data you want back, if you can't tell from all the data you've collected right now whether or not your systems are available, you might need to write more code for that. More code might need to exist to run automatically to find out if your systems are available. Maybe they're kicking off a test to make sure availability works from different regions. Lots of ways you can do it. Think about your SLIs for how to actually instrument those. So this is where, by the way, software engineers and ops and QA, you're all starting to intermix because you're all thinking about the same problems here. Yeah. Observability is testing in production. We should do that. Test in production. Throw her on the rack. This doesn't eliminate QA or testing. That's not what I'm trying to say at all. Right? You definitely should absolutely test your code before it gets to production. But the staging environment is sort of passé, especially if your whole goal is to understand exactly what production looks like with observability. Why should we do this? Whose staging environment actually matches their production environment? For the record, that's 0 people in the room. Can you actually replicate your production traffic anyway? Like the best analogy I heard from this was the national power grid. There is no way there can be a staging version of the national power grid because there's no possible way they can replicate the output or the demand on any sort of meaningful scale without just creating another one. And you definitely can't replicate real users. Like if anyone who builds a platform service, which basically lets developers or other people do kind of whatever they want inside of your product, you are never going to think of all of the ways that that system's going to be abused. So yeah, we talked about feature flags and canary deploys. This is not the talk for those, but this is what should largely replace your staging environment. And if you have proper observability written, you have proper observability into your systems, all those deploys can be monitored. You can understand whether or not they're working, and you should be able to roll them up and back. You should turn up how many users are exposed to it, be able to turn that down. But that's a different talk. But think about this, right? This is something that QA engineers have been working on. They've been trying to write tests to understand how does our software perform in production-like environments. So if you need help writing your test to figure out how your software performs in, I don't know, a production environment, ask your QA team. They've been doing it already. They've been trying to solve this problem. So they can help you actually do your observability in production. It's just you're applying it to different systems. They can help you start leveraging a common tool set. I can talk to you more about that somewhere else, but the idea is if you're using the same tools to understand how your service is performing, now you can start having a common language, and you can actually start working together a little bit better than when QA uses the QA tools and Ops uses the observability tools. They can be the same tool set. Every dashboard sucks, which someone is really upset about. But not really. Some dashboards are actually quite good, which the other half of you are now upset about. So dashboards are about storytelling. They're not a great debugging tool, but they're a great storytelling tool. They create a context around your data that's sort of hard to receive on the fly or without it all being there and available to you. The great analogy about this is like, think of a great book versus a great film. They tell stories in a fundamentally different way. So when you're debugging code and debugging your production, you don't care about the same stories as your dashboard is telling. So you shouldn't use dashboards as your way to debug everything. So what does ops and incident response care about? Like when you actually need to debug your production? It needs to be interactive, right? You need to be able to slice that data. If it's just a dashboard that you can't change or slice, not useful. It needs to be iterative. So once you slice that data, can you go further? Can you add more to that? Can you change it? Can you shift it around? There's tools out there that use dashboards to start correlating this data, and there's ways you can use dashboards in an interactive and iterative way. But start thinking of them not as a, I built this thing to show me when stuff goes wrong, and more of a, I'm using this as a tool to correlate my data together. Your dashboard might only exist for the time that you're solving the problem and then never be useful again. Vendor alert, I think your dashboard should involve search bars. We also have common data schemes. I think it's important to be able to query your data across all of your monitoring systems with a common scheme so that if you're looking for a user ID or a host ID or what have you, you can start pulling up your metrics and your logs and your APM in one place. I think largely these are search problems, because if you're searching for a needle in a needle stack, you're searching ultimately. But I work for Elastic, and we're a search company, so take that for what you will. All right, so this is kind of how to do this thing, and this is a good starting place for starting this yourself. How do we actually enact this in our organizations and get people to care about it? Okay, I will go quick. Don't just start making changes. Don't hear this talk and get back and immediately start changing stuff. I know, but I just heard the conference talk and I really want to. The history of your org is important. Understanding why you're monitoring what you're monitoring. For instance, you still have systems deployed on bare metal, right? It's important to not change how you're monitoring that, because that might be the right way to monitor that system. Change implemented poorly breaks things. This is the schism part of the conversation. I think top-down mandated change is problematic. I think you need to have some grassroots buy-in, and proving that there's value to your changes is important. Otherwise, you get thrown out windows if you're in Prague during the Protestant Reformation. Yeah, so it's important to talk to the parts of your business. If you want to understand how your business makes money, how those customers move through your funnel, you need to talk to them. And by talk to them, I mean you need to listen to them. It's important to ask those questions about it and understand the context that you're fitting in and what value you're actually providing to that stream. Start measuring your business values. Who else in your org cares about dashboards? Where might these be useful if they're not great for ops? This is why dashboards actually are pretty good. We'll think about what data we can expose to the rest of the business. SecOps, or SecOps, security operations. Yeah, this is airplane-like security line data. This is probably useful for someone. And it's probably really good as a dashboard because a human has to make a decision about this data before it can be acted on. Where if this was just purely computer systems running through, you're probably going to build a lot of automation and alerting rather than a dashboard that someone has to watch and make a decision about. It's all about the context of where that data is coming from. Marketing might care about dashboards. Sales, these are terrible revenue graphs in the big picture, but they look real pretty. So guess what we were selling at this time. But anyway, think about revenue. Are you actually measuring your business's revenue? Would that be something useful that people in your business would care about and be able to like display on a dashboard alongside other system operations standpoints and how your services are performing, like whether or not your credit cards are getting declined? This is valuable information that you may not be tracking alongside the service that you're providing. But understanding your service performance and your revenue together is probably a really important relationship. So yeah, hopefully I've sold you. Dash bells tell stories with context. Share results. So good and bad of these results. All right, so here's the question. Are your systems up? Are they responding acceptably? Who cares? It doesn't matter. I know, one more. Are your services delivering value? This is what we need to start thinking about when we're trying to measure our monitoring. All right, thanks.